All right, Math 3, we are starting section 6.5. We are going to be solving radical equations this time. Solving means you can always check your answer. There will be equal signs, so you are solving for x, not just simplifying down. So I would encourage you, if you are unsure of an answer, replace it back in for the x, and it should work to be a 0 when you finish the problem. All right, what you're going to do in this one, you want to isolate the radical, get it by itself on one side, all right? So if you take a look, treat this almost like we're a big X right here. So you have X minus 5 equals 0. So you're gonna add your 5 over, so you have the square root of 4x plus 1 is equal to 5. Now, to get rid of a square root, you square both sides. The square and the square root cancel, so you get 4x plus 1, and over here now we get 25. Now it's just a basic algebra problem. You're going to subtract that over, and you get 4x to equal 24, and then you get x to equal 6. Checking back in, you're going to put 6 here, which is 24. 24 plus 1 is 25. The square root of 25 is 5, and 5 minus 5 is 0. So there's your answer. All right, so over here, you need to, again, isolate this radical. So your first step would be to subtract that 3. So you get 3x is equal to 12. Now you'll divide both sides by 3, and you get a 4. Then you're going to square both sides, and you get 16. And the story, you can try it in here if you want. The square root of 16 is 4. 4 times 3 is 12, and 12 plus 3 is 15. All right, add your 7 over. So you get the square root of 2x plus 3 is equal to a positive 7. Square both sides, gets rid of the square root. You get 49, subtract 3 over, you get 46, divide by 2, and you get 23. Okay, on this one, what it is saying, if you look at the little gray box here in the middle, is if you have a fraction, you're going to multiply by its reciprocal to get it by itself. Now, it also says in here that if either m or n is odd, even, then you're going to need some absolute values when you go to do that. All right, so like in this instance right here, you have the numerator is an even number, so you will need some absolute values. That means you have 2 answers. I'll show you in a minute. All right, so the first thing you're going to do is go ahead and divide by 2. All right, now when you multiply by the reciprocal, which is 3 over 2, you get x plus 3 equals, now this is where we worked last section, you're going to take the square root of 4, which is 2, and 2 to the 3rd power is 8. All right, so what you're going to do is you need absolute values on this side. So how you work this is you would say x plus 3 is equal to 8, and x plus 3 could equal a negative 8. So you will end up with 2 answers in this instance. All right, so you're going to subtract 3, you get x to equal 5 here. You're going to subtract 3, and you get x to equal negative 11 here. Let's go back up to the original problem and check our answers. All right, so if we go and we stick a 5 in here, 5 plus 3 is 8. The cube root of 8 is 2. 2 squared is 4, and 4 times 2 is 8. Take the negative 5, put it in here. Negative 5 plus 3 is negative 2. Or negative 11, I'm sorry. Put negative 11 in here. You get negative 11 plus 3 is negative 8. The cube root of negative 8 is negative 2, but negative 2 squared is 4, and 4 times 2 is 8. Because you're going to be squaring, you can either have a positive or a negative in here when you go to do that, and both of those give you the answer of 8. All right, the denominator here is an even, so we will do the same idea with this. So you are going to divide that over first. Okay, you get 8. Now you're going to be multiplying both sides. I'm just going to write this one because I know that it will cancel. But you're going to be multiplying this side by the reciprocal, which is 4/3. So the cube root of 8 is 2, and 2 to the 4th is 16. All right, so x minus 2 could equal 16, or x minus 2 could equal a negative 16. So you get x to equal 18, or x could equal negative 14. Let's go through and do this. If you put 18 in here, 18 minus 2 is 16. The 4th root of 16 is 2. 2 to the 3rd power is 8. And 8 times 3 is that. If you take negative 14, put it here, you're going to get negative 16 And if I cube negative 16, I'm wondering if, I feel like it's only the numerator that it would be the even, but anyway, you get your negative 16, which will give you the 2, and when you cube it, you're going to get 8, and 8 times 3 is still 24. Okay. All right, let's take a look here. I don't think we've done enough word problems. Well, this one's dealing with problem number 3 that was in the book, but they will give you formulas. So a spherical tank holds this much water. What is the diameter of the tank? So when it holds water, that is your volume. So you will put 9,000 right here. So you have 1/6 d to the 3rd pi is equal to 9,000 cubic feet of water. Again, you are solving for D, so you multiply both sides by 6. I don't have a calculator. I mean, multiply both sides by 6, which isn't a big deal. You get 5,400 or 1,000 over here. But then you need to divide by pi, both sides by pi. And then to get rid of a 3, you take it to the 3rd power, which is the cube root. So you're going to divide this by pi. And then once you get that answer, you're going to cube root it because you're going to be taking it to the 1/3 power, which is the cube root. And then what you'll do is just kind of round it to whatever, put it in there. All right, the same thing will be here. You'll just plug in the things you know, and like you have d to the 2nd power here. So if you were trying to find your d or anything like that, you would take it to the 1/2 power or square root to get that by itself. All right. Okay, over here, what happens is you're gonna, when you raise each side of an equation to a power, it is possible that you will get something what's called an extraneous solution, which means basically you are creating a solution. It's one that doesn't really work in the original problem, but by having to solve it the way we do, an extraneous solution will give you a false statement. So you might have 2 answers, but one of those answers will not work. All right, so you're going to be doing the same thing as you normally did. You want to isolate this radical. So let's go ahead and subtract that 3 over. So we get x minus 3 over here. Now to get that, we need to square it. And you square this side, okay? So I know on this side, I'm gonna get 5x minus 1. Now over here, because it now is a binomial being squared, you need to write it out twice and FOIL it. And if you FOIL this out, you're gonna get x squared minus 6x plus 9. Now, do you remember what we talked about a long time ago? Is you always have the number of solutions as your highest exponent. Well, by squaring this, you just created an x squared that wasn't in the original problem. So there's where your extraneous roots come in. All right, so what we're going to do is get everything to one side and see if we can factor it or use a quadratic formula, whatever works, because we now have a quadratic equation. All right, so I have the x squared. I'm going to bring the 5x over, which gives me a negative 11x. I'm going to add my 1 over here, which gives me 10. Set it equal to 0. So it looks like x minus 10, x minus 1 will be our factors, which means x could either equal 10 or 1. All right, well, let's see if they work. So let's put a 10 in here. You're going to get 50 minus 1 is 49, and 40 square root of 49 is 7, and 7 plus 3 does equal 10. I'm putting 10 in for both x's. Take a 1, put it here. You're going to get 4 inside. You're going to get 5 minus 1 is 4. The square root of 4 is 2, and 2 plus 3, remember I put a 1 right here. So 2 plus 3 does not equal 1, so the 1 is my extraneous root. The only actual answer that worked was 10. So when you look at this and you see it was not squared, but you have a square down here because that's the only way we know how to solve it, chances are one of your solutions may not work, so you have to go and check them in there. All right, so on this one, same idea. We're going to square both sides. So when I square the radical, it's already isolated. I get what's underneath. Over here, I'm going to be foiling, so I get x squared plus 6x plus 9. Gather everything to one side. So I have the x squared. I'm going to add the 3x over here. I'm going to add that over here to give me 14. Looks like 2 and 7. So x plus 2, x plus 7. So we're going to x equal negative 2 or negative 7. All right, we're going to check it. If I put a -2 in here, I get 6. 6 minus 5 is 1. Square root of 1 is 1, so this side's a 1. If I put -2 in here for the original, I also get a 1. -2 plus 3 is 1, so that worked. -7 in here gives me 21. 21 minus 5 is 16. The square root of 16 is 4, so that side's 4. If I put -7 in here, I get a -4, and 4 does not equal -4. Therefore, -7 does not work. There's my only answer. Okay, here, you're going to add the 1 over. Remember, this is just a square root. 1/2 is a square root, so this is really the square root of x plus 3 is equal to x plus 1, because you're going to add that over. You square both sides. You got the idea. Okay, when you're solving something here with 2 radicals, you are going to square this side and square this side. Well, I don't know. I think it might be, let's just bring that over. I think you can do it either way, but I feel like that might be a little bit easier. Let's just go ahead and bring that over. You're going to get 4 plus the square root of x. Now let's square it, because this side will make it easy. X plus 4. This side, we are still going to have to FOIL that out. So let me write that out, and we'll do a whole FOIL. All right, so you're going to take 4 times 4, which is 16. You're going to get a 4x squared and another 4x squared, which is 8x, the square root of x, and then the square root of x times the square root of x is just an x. All right, now get everything to one side, and then what you're going to do is square that again. All right, so I'm going to subtract this x over, gives me a 4x. I'm going to subtract that 16 over, don't do that, which is -12 equals this. All right, so now I'm going to, I could divide by 8. There's just so many ways to do this. Squared, I'm going to go ahead and FOIL this out, which is 8x squared. That gives me 48, -96x plus 144. Then over here, I'm going to square both of these, so I'm going to get 64x. All right, so bring it all over to one side. 8x squared, let's see, what's 96 and 64? 15, that's 160. All right, so minus 160x plus 144 is equal to 0. I'm guessing you can pull an 8 out of all of this. So if I pull an 8 out, that goes in there. Let's see, once 18 times, okay. All right, so factoring this down, we have x. Let's see, does that factor? 6 and 3. Probably should have done this one ahead of time. Can't think of anything that factors into. We have 9 and 2, 18 and 1, 6 and 3. We may have to go to our quadratic formula for that to solve for our x. And again, once we do that, and maybe I made a math error somewhere, but let me look through and see what I've done. But anyway, you get the idea. Once you get your x values, you'll need to replace them back up here, and believe it or not, it does work out nice to equal 4. So yeah, I'm just trying to see if I did anything wrong, which is definitely a possibility. Okay, let me think on this, and if you have any questions, just let me know. On this side, again, when you're doing something like this is again just square roots. So you have the square root of 2x, and over here you have the square root of x plus 5. You just square both sides, so you get 2x equals x plus 5. So x is equal to 5. And if you plug it in, you can see if it works. And it does, because this is going to give you the square root of 10. You get over here, you get the square root of 10. So always check for your extraneous roots on any of those. It looks like it's probably about it. And I will put your homework on Google Classroom. Let me know if you have any questions.